Thank you. Do you know, 25 years ago this week, I was in my last few days at university. I was desperately trying to finish my thesis on the practical applications of artificial intelligence. 25 years ago, a quarter of a century. Wow, that makes me feel old. And now I'm imagining you all sitting there looking at me thinking, only 25 years since he was at university. He hasn't aged well, has he? He looks a bit older than that. But you might also be thinking, it's 25 years later, and we're still discussing the practical applications of artificial intelligence. The difference, of course, is that back then, by and large, it was mostly computer scientists like me and the odd Hollywood scriptwriter thinking about it. Today, everybody's talking about it. 25 years ago is before Netflix, it's before Facebook, it's before smartphones, it's even before ArcMap. And now I imagine some of you are reeling from the idea that there was once a time before ArcMap. But actually, does anyone here want to admit to having used ArcInfo Workstation or ArcView 3? Put your hands up. Let's see if there's a few of you. There are quite a few out there. Actually, I don't know why I've got my hand up, by the way. This was a few years before my love affair with geography started. Actually, I'm going to come back to the practical applications of artificial intelligence and geography in a minute. But I need to pause and introduce this final session of today that we call the road ahead for ArcGIS. In particular, I want to highlight something that Pete talked about right back at the start of today. I want to highlight what we at Esri are working on to make ArcGIS easier to use. That's easier whether you're an IT professional or a developer rolling out location services across your business, or perhaps whether you use geography and GIS in your day jobs. Now, as Jess said, in a minute, I'll be joined on stage by Arthur and Kristian, who will talk through a couple of specific areas of research. But first, let's remind ourselves of this idea from the opening plenary, this idea that we can use geography and GIS as a digital abstraction of our world. This geographic approach allows us to understand where stuff is. It allows us to understand why stuff is there and how it's changing. And it allows us to make predictions. And then we can use this model, this abstraction, to make decisions and apply them back in the real world. And throughout today, we've seen many amazing examples of this from you, our users, such as the 3 winners of the Customer Success Awards. The things that you do with the tools that we build inspires us. It inspires us to innovate and improve our software. As you may know, we do this through a huge annual investment in research and development, as well as what I hope is a healthy obsession with these word clouds. Importantly, or perhaps I should say seriously, we get this improvement, this innovation to you rapidly through continuous improvements in incremental releases. Taking this calendar year as an example, just a few weeks ago, we released new versions of ArcGIS Pro, ArcGIS Enterprise, and updated ArcGIS Online. And before the end of this calendar year, we expect to have released updated versions with lots of exciting new capabilities. So let's dive in and take a little look at some of those. In ArcGIS Pro, you can expect many advances in areas like data science and administration. For example, new geoprocessing tools to make it easier to do flood simulation modeling in 3D, and the ability to create map-rich presentations directly in ArcGIS Pro, allowing you to take the results of your analysis to new audiences and present them in new ways. And finally, we are, getting 64-bit object IDs, something that is a common request from those of you working with billions of features. In ArcGIS Enterprise, a new capability to manage and serve geo-referenced video, perhaps captured by drones, is going to be very, very powerful for some organizations. For example, to allow you to discover and view real-world video observation, either to help you create a more complete common operational picture, or to incorporate into your analysis workflows. Our Kubernetes deployment option is getting support for Rancher, allowing organizations to better manage their container infrastructure at enterprise scales. And ArcGIS Knowledge, this incredible geospatial graph database capability that Mark talked about in the opening plenary, is getting a web-based user interface, allowing it to be accessed more easily by more people in your organizations. Next month's ArcGIS Online release is getting updated Experience Builder widgets to support the nearby and screening functions. And later this year, we can expect a capability to restore deleted items, a kind of recycle bin, which I must admit is something that I've needed more than once. And data pipelines will bring drag and drop ETL functionality to ArcGIS Online, allowing you to more easily incorporate your own organization's systems and data into your WebGIS. So to summarize, when I look across the whole of ArcGIS, there is loads of new functionality coming, even just in the next 8 months or so, to help you make better use of geography, of this digital abstraction of the world, and make ArcGIS even easier to use. Now, I promised to return to the subject of artificial intelligence and geography, or GeoAI, as we sometimes refer to it. This is a map of air quality in London. I actually took this screenshot last week, but you can go on this website and look at this data live. You can look at this map live, or at least it's updated several times a day. How do we do this? How do we measure the air quality everywhere? Do we have sensors everywhere? Well, there are actually quite a lot of air quality sensors in London, but there isn't one to represent every single area of land represented by each cell in this raster. No, we have to make predictions. We have to predict the state of the world at unfamiliar locations based on data that we do have. And when I stopped to think about it, I realized that the GIS process that created this map actually meets many of the definitions of artificial intelligence, although it's a long way from the sort of things that we normally picture when we imagine an AI. Actually, one of the best tools to do this type of analysis has a fantastic name. You may know it. It's a type of kriging called the empirical Bayesian kriging. It's also a machine learning algorithm in that it runs repeated simulations to converge on an output. And this particular tool has been in ArcGIS since 2012, as you can see from this ancient screenshot of our help documentation. But even before that, those of you who put your hands up earlier and admitted to using ArcInfo and ArcView3 were using analysis functions that arguably can be thought of as artificial intelligence. Did you realize that you have been using ArcGIS to do AI-powered data science for a generation? Well, that's a little bit of history. Let's bring things up just a little bit more up to date with a cartoon. You may have seen this cartoon before. I absolutely love it. It describes two things. It describes what we in this room and online watching at home probably know as a simple GIS function. And also it describes a really hard prediction problem that we normally solve through a type of machine learning that these days we refer to as deep learning. Deep learning is a little bit different from the statistical AI that has been in GIS and other data science products for decades, in that with deep learning, you typically don't need to understand exactly how your algorithm is modeling the world. You only need to understand whether it's doing it correctly or not. But the really funny thing for me about this cartoon is the date that it was published, 2014. Less than 10 years ago, this type of image recognition was so hard, it was a joke. These days, I can do this over an API in milliseconds on a commodity basis. These days, it's almost so easy it's a joke. So what has changed? Well, the first thing that has changed is computing power, and in particular GPUs, which is what has actually allowed this type of machine learning to become deep in the first place. And we at Esri have taken great advantage of this, actually. We've included in our products for probably 5 or 6 years now a whole set of tools to allow you to incorporate deep learning into your analysis workflows. And as we talked about in the opening plenary this morning, we also make available to you in the Living Atlas of the World a whole range, a growing range, in fact, of pre-trained deep learning models that you can download and use straight away. Remember this is actually really important. Using these pre-trained deep learning models in ArcGIS Pro or ArcGIS Online is just as easy as running any other geoprocessing or analysis tool. You can start doing this tomorrow. Now, if you want to go further, for example, training on your own data, you can do that in ArcGIS Pro, or from ArcGIS Enterprise 11 onwards, we've included a new web application called ArcGIS Deep Learning Studio that we have built to streamline the entire machine learning and deep learning workflow for geodata. So that's the first thing that's changed. The second thing that has changed fundamentally is scientific advance, which has led to new ways of describing the world within these models, and it's led to new ways of training them. So let me try and show you what it can do. Hal, are you there? Hal, can you map my restaurant's data set up on the big screen for me?
I'm sorry, Adam. I'm afraid I can't do that.
And that's why they don't let me do the live demos. Arthur, can you spare my blushes, maybe?
So thanks, Adam. And good afternoon, everyone. So unfortunately, we're still a little ways off from this sci-fi vision of truly sentient AI. However, what I'd like to talk to you about today instead is a new class of AI models, and something that's made headlines recently for perhaps bringing us one step closer. And this is generative AI. So generative AI, broadly speaking, is able to create novel text, images, video, audio, even 3D models based on the patterns learned from training data. Now, I'm sure many of you have had your minds blown at least once in the last couple of months by a photorealistic image produced by something like Midjourney, or a natural conversation you've had with a chatbot like ChatGPT. And these are both examples of generative AI. So what does generative AI mean for us in the geospatial space? Well, for starters, they enable us to make things like this map of the Isle of Wight, styled to look perhaps like an old pirate's treasure map. Now, of course, I'm not going to spend the rest of the session talking about novelty map styles, although I easily could. Instead, I want to show you how generative AI can give us a head start and streamline many common GIS workflows. So one type of generative AI is a large language model, or LLM. And these models are designed to understand and generate natural-sounding text. ChatGPT is probably the best-known example of a large language model, but there are others. Now, across the internet, there is a wealth of information in a variety of data sources like reviews and blogs, and other types of what we might call unstructured text. Now, it has been possible for a while to extract key information and geospatial data from these kinds of data sources using machine learning. However, this has typically been challenging and time-consuming to do, and difficult to do reliably. Now, one of the key abilities of large language models is the ability to understand and to restructure information. And we can use this ability to not only extract key information from unstructured data sources, but also to categorize this information and even predict the degree to which it is positive or negative using a technique called sentiment analysis. So as an example, here we have a blog article of the best restaurants in London. And if we wanted to map this it might be quite a time-consuming task to go through and summarize all of this information. So let's ask a large language model to help us instead. So here we've created a notebook in ArcGIS Notebooks, and I'm not going to go into detail into explaining how this works, but essentially here we're sending a request off to OpenAI's GPT model, and this is the same model that powers ChatGPT. Now we tell the AI the structure of the data that we'd like to output, and then we feed it the text from the blog article, and it returns stuff that looks like this, nicely structured data that we can then further process into a table, and then plot on a map using geocoding. And the result of that is this. So here now we have a map that shows all of those restaurants plotted as points on a map. And if we click on one of these, we can see the information that's been extracted by the AI. So here in this case, it's picked out the address, and this is what we're using to locate the point on the map. It's given us a summary of the cuisine, and it's given us a short text summary based on the information in the blog article. Now, it's also generated this rating here, and this rating wasn't in the original article, but based on the degree to which the text was positive, i.e. the sentiment of the text, the AI is able to predict what a review score for this restaurant might look like. And so here, using a large language model, we've been able to extract and categorize key information from an unstructured data source quickly and easily. But large language models aren't just good at summarizing information. Let's now say we want to take this a little bit further, and we want to find which of these restaurants are within easy walking distance of the QE2 conference center where we are right now. And to do this, we're going to need some spatial analysis. Now, perhaps as a relative newcomer to the world of GIS, we might be a little bit daunted by the wealth of analysis options that are available to us. It would be an easier experience if we could simply ask a question and get back information about the workflow that we would need to follow to answer this question spatially. And so to this end, we've added an AI assistant into MapViewer. And let's ask our AI assistant for help. Let's say, how do I find locations within a 20-minute walk? And here we're getting a response back. And it's suggesting that we use the Generate Travel Areas tool for this analysis. It's giving us a brief summary of what this tool does. And now we're getting step-by-step instructions on how to access and use this tool to answer our question. Now, I've already gone ahead and followed the instructions given by our AI assistant. And so here's one I prepared earlier. This is the result of this analysis workflow. And here we now have an area that represents what can be easily reached within a 20-minute walk from the QE2. Now let's say we want to extract the restaurants from our layer that fall within this area. And this is going to require some further analysis. So again, let's continue the conversation with our chatbot and ask about this next stage of analysis. Let's say, that's great. How do I find which points in my restaurants layer fall within that area? And there we go. The chatbot's now continuing the conversation. It's suggesting now that we use the overlay tool, and it's giving us step-by-step instructions for how to use this tool. And these instructions are tailored to the particular question we've asked. So here it's telling us to use the intersect operation. So with very minimal GIS understanding, we've been able to simply ask questions and get back the workflow that we would need to follow to answer those questions in a friendly and conversational way. And so again, I've gone ahead and followed the instructions from our AI assistant, and the result looks like this. So here now we just have a map that shows the restaurant locations that are within a 20-minute walk of the conference center. Now, this is a perfectly serviceable map, but it's not particularly inspiring visually. And it doesn't really fit the theme of restaurants that we're going for. Now, if I was to style this map myself, there's a number of creative decisions that I'd have to make. I'd have to choose an appropriate base map. I'd have to choose appropriate symbology and an appropriate color scheme. And some of you can probably see where I'm going with this already. But what if we asked our AI assistant for help with this too? So let's tell the AI the topic that we're mapping, in this case, restaurants. And then let's tell it to use the rating attribute that we created using sentiment analysis in our first example to symbolize the data. And so now with a bit of processing, we're going to hopefully get a new map style. So here the result we've got back is a little bit interesting. But let's take a second to break down what just happened. So we sent off 2 requests again to OpenAI's GPT model, and we asked for a suggestion for a base map style that fit the theme of restaurants and an appropriate color scheme. You'll also see that we've generated a symbol here, and this symbol was generated using another generative AI called Stable Diffusion, which is an image generator. Now, of course, this is a general purpose model. It's not been trained on cartographic principles, and so the map that we've got back isn't the easiest to read or the nicest looking. But let's try again, and this time we'll be a bit more specific in our request. So rather than just saying restaurants, let's instead say gourmet restaurants. And again, we'll tell it to use the rating. And now, again, here we're sending off requests to the GPT model again. And we get back some different suggestions. So this time, it's picked a slightly more artsy style, and it's picked a more subtle color scheme for our points. And so, even though this is a general purpose language model, it's been able to make decisions that are perhaps somewhat similar to what decisions a human might make when asked to make a map of gourmet restaurants. This is quite impressive. So far, we've been looking at what's possible right now with commercially available AI tools. But the field of AI is always advancing, and there are research projects in the works around the world that enable these large language models to operate autonomously without human intervention. And this allows them to execute much more complex and multi-stage processes by first planning and then executing each stage of a process. And so, in another example, here we have a blog article of the best beaches in the UK. And let's say we want to summarize this article into a story map. Well, let's ask our now autonomous large language model for help with this. Let's say, create a story map on the top 10 beaches in Britain from this article, and then we'll give it the link to the article. And now here it's going to first plan how to execute this task. And then it's going to follow a lot of the same processes that we've already seen. So here it's summarizing the text in the article. It's now going to use the location information it's extracted from the article to geocode points on a map. Now it's going to pick an appropriate base map theme and color scheme that fits the topic of beaches in this case. And now it's writing a short Python script to summarize this information and create a story map. So here we have now a story map, and for every beach here, it's summarized the text that it's extracted from the blog article, and it's even extracted the image URL from the article to help illustrate the story map. And this gives us a nice head start that we can then adapt further for our own needs. So, as we've seen, generative AI is able to give us a head start in many common GIS workflows. It allows us to gain new understanding by accessing and summarizing new data sources like unstructured text. It offers a friendly interface for interacting with GIS in a conversational way, making GIS more accessible. And it also gives us a head start by making some of the key creative decisions for us. Now, of course, the field of AI is always advancing. And so, as we better understand how to first use and utilize this technology, and also to benefit from it and implement it in our own workflows, it has the potential to fundamentally change how we interact with GIS, and frankly, everything else. So thank you, and back to you, Adam.
Thank you, Arthur. That was really superb. And I think always a danger with doing live demos like that in front of 4,000 people. I've seen that demo work flawlessly, probably 5 or 10 times. But at least it doesn't demonstrate that we weren't using smoke and mirrors there. We were actually trying to use artificial intelligence to dynamically generate that story map. Now, while the things that Arthur talked about are pure research, you can expect us to start incorporating some of this type of technology into our products in the very near future. AI-powered assistive technology is not going to replace us, but it is going to support us in our jobs. It's going to make ArcGIS even easier to use and more accessible than ever. Now, talking of accessibility, if you were at the conference last year, you might remember how we talked about how important it is to us, and in fact to you, that anybody can use our software. The accessibility of ArcGIS. And in the last year since then, we've made many more improvements. For example, next month's ArcGIS Online release is going to include updates to Experience Builder to make sure that your web mapping applications work even better with assistive tech, such as screen readers. And also in the last year, we've made updates to our Ordnance Survey base maps to include a set of styles specifically designed to provide high color contrast. But that got us thinking. We can make our products, our apps, our services, our tools really accessible to almost anyone. But particularly for people with visual impairments, current technology does not really do justice to the map itself. We tend to rely on a fixed, static, alternative text. Is that the best we can do? Well, to answer that question, I'd like to ask Kristian up onto the stage. Kristian.
Thank you, Adam, and good afternoon to you all. Over the next 10 or so minutes, I will explore with you a completely new way to engage with ArcGIS and maps. But before we get into that, I would like to mark a very special occasion. I heard that someone in the audience is celebrating their birthday today. How amazing, but I don't know who it is. So if it is your birthday, could you just give me a wave of hands so I can find you? And I know you're here somewhere, so there's no need to be shy. You won't even have to come on stage. You can be seated. We're all friends, so just show me your hand. Oh, am I seeing anyone? There you are. Happy birthday, and thanks for being here with us. That's really great. Have you had anyone sing happy birthday for you today already? No? I'm really sorry. Maybe I can make up for that. Have you ever had 1,000 people perform happy birthday for you? No? Well, there's a first for everything. I hope you're all with me. But don't worry, no singing required. Instead, we're going to play happy birthday using our smartphones. And we will do that. Here it is. We will do that by using our smartphones. And please, having a musical jam session with this many people is just asking for something to go wrong. So try to follow my instructions closely. In a second, I will show you a QR code that takes you to a website, and as a warning, that website works by touch. So don't be that person who's too eager and starts touching straight away. Just wait for me, okay? As a first step, though, let's get our phones ready, unlock them, and increase the audio volume to the max. And if you have an iPhone, don't forget about the mute switch, otherwise your instrument won't be working. Then, the QR code. Use your camera app on your phone, point it at the QR code, and a link should pop up on your screen. That takes you to a website. That website has the Esri logo, and as it says on the warning underneath, don't touch it, for now. This website is our instrument, and it works by touch. So anytime you touch it, a tone will play. All you have to do is tap along to the rhythm of Happy Birthday. Easy enough, right? So I'll give you another second to get ready and put on my party hat. Could you give me a thumbs up if you've got the Esri logo in front of you? Brilliant, that's most of you there. So let's tap the screen once, which will make the logo disappear, and you have a blank blue canvas in front of you. And then on the count of 3, we'll start tapping. Good luck. 1, 2, 3. Happy birthday to you. Woohoo! Amazing. Thank you everyone for your help. And happy birthday once more. Wow. Isn't it incredible how the simple act of playing an admittedly quite chaotic version of Happy Birthday can create these emotions of togetherness and community and fun in us. And indeed, it was music that got us thinking in the first place. There has to be a way that we can use audio to improve our maps and make them more accessible, more inclusive. Because let's face it, maps are exceptional at conveying information, but their visual nature can create a real challenge for visually impaired users. So let's bridge that gap between audio and GIS and create something that doesn't rely just on visuals. Imagine a map that communicates with you, that lets you analyze and retrieve and edit your data by speaking with it. That sounds like the future speaking, doesn't it? But that's what we do, and the research team has worked really hard for me to be able to show you this. That's working. For me to be able to show you this. And yeah, an audible map. I'm not going to be able to pretend to have the same vision as a visually impaired person, but I think what I will show you now will help all of us to engage with maps in a new way by supplementing it with audio, create a more immersive experience. To demonstrate this app, we're going to review a fictional planning application that was flagged as potentially controversial. Let's have a look.
Welcome to Audible Maps. Start exploring by typing or saying commands.
Straight away, we're being greeted by a voice prompt. This is one of the main features of the application. It has the ability to understand and respond using natural language. Let's see what else we can do with this map. Tell me about the map.
You've asked for information about the map. This is a web map showing proposed wind farm on Arthur's Seat, Edinburgh. The map contains 5 layers. 1. Sites of special scientific interest. 2. Proposed site roads. 3. Extent of the site area. 4. Proposed turbine locations. And 5. Visibility of the wind farm.
A wind farm right on top of Arthur's Seat. That is controversial. What other questions can I ask?
You can ask me questions about the site area, visibility from an address, or information about the turbines.
Visibility, that's interesting. I wonder how many of these turbines are visible from Calton Hill, another popular viewing place in Edinburgh. And if you're in a busy environment or otherwise unable to speak, typing works just as well. How many turbines are visible from Calton Hill?
You've asked for visibility from Calton Hill. 9 turbines are visible from this address.
That is a lot. I'm not sure if I like this plan. So far, our interaction with this app has been similar to a screen reader, although spatial. The responses were either generated from the metadata of the layers or the map, or, in the case of the visibility question, it was the result of a full workflow. Under the hood, the app had to resolve a geocode request to get the X and Y of Calton Hill, then query the visibility layer, and then return the response in full-text speech. Still, it doesn't tell us very much about the spatial relation of individual features and layers. And to make that more accessible, we've implemented an exploration mode. Let's explore the map.
Relationship exploration mode enabled. The site boundary sounds like this. The wind turbines sound like this. Triple SI sound like this.
While in the exploration mode, 3 of our layers are represented by different tones, and they play in relation to our cursor. If I was on a touchpad, it'd be my finger. That's even better because then you're more direct. As I enter the site area, you can hear this warm background noise playing to indicate we are within our area of interest. And you'll hear now as I pan across and approach a turbine. There's a faint noise appearing, and as we get closer, it'll grow in intensity to indicate the distance to the closest turbine. For those of you in the room, you'll have noticed that that sound came from the left, because we also show the direction towards the nearest turbine. It'll become more clear as we go around this northernmost turbine. You could hear it go from the left to the right and back. The final sound is introduced when entering the SSSI, a site of special scientific interest. This is a protected area, and our site area should not overlap. And to indicate that restrictive nature, we've given it quite a sharp warning sound. So we don't want to hear that, especially not at the same time as our site area sound, but it happens. Not good. And even worse, a turbine falls as well within our site SSSI. Let's find out more about that nearby turbine. Tell me about the nearby turbine.
Turbine 1 is 104.4 meters high with a capacity of 2 megawatts. The status of this turbine is currently set to approved.
Approved. Clearly an oversight by the person authoring this map, so let's update this. Update the status of turbine 1 to rejected.
The status of turbine 1 has been updated to rejected.
Great. And with that, the map will go back to a colleague to make a decision on what should happen to this turbine. Thank you.
You're welcome, Kristian.
That's more. Let's reflect for a second on what we've just shown you. By designing this audiovisual map experience, we've created a new way for all of you, but especially people with visual impairments, to engage with maps. It will be a while before you find such a feature in your everyday GIS application, but when we get there, it'll be worth it. Especially if you think back to Arthur's talk on generative AI, it doesn't take much to imagine how an AI-powered version of an audible map will let us push the boundaries of immersive mapping to completely new heights. There'll be a lot of innovation coming, and I'm really excited to see what all of us will do with that. But don't be fooled. The advent of AI alone will not bring accessibility by default. It will be up to all of us to ensure that new features and new products are implemented with accessibility in mind. And as you leave this conference and return to your daily jobs tomorrow, I would encourage you to review and embrace accessibility best practices whenever you create new content. Together, we can create a world in which accessible GIS becomes the norm, not the exception. Thank you. And with that, back to you, Adam.
Thank you very much, Kristian. Actually, I completely agree with you, Kristian. I think when I reflect on Arthur and Kristian's work as a whole, it seems entirely possible that in the near future, that static, fixed alternative text that I talked about will be replaced by a range of different experiences that are dynamically generated from the map and ones that adapt to our individual needs. AI tech already exists that, wrong slide. There we go. AI tech already exists that can summarize images at a high level. Think what it could do with the rich data and metadata that power your ArcGIS maps. Well, you know, it's taken 25 years to get here, but that brings us to the end of our session this afternoon. We have discussed some of the new things that are coming in ArcGIS. We've taken a bit of a history through GeoAI and shown how it can lead to new ways of making maps. And we've had a bit of fun on what is actually a very, very serious topic, the accessibility of ArcGIS itself. Our continued investment in the development of geospatial technology is going to make ArcGIS even more easier to use and more accessible than ever before. And we at Esri can't wait to see what you do with it next. Thank you very much, and back to Jess.
Thanks, team. And what a fantastic insight into what's coming up later in the year, and what a way to wrap up this year's annual conference. I would like to thank you all for joining us today. Your continued support and participation throughout today is appreciated by myself and all the Esri family. Most importantly, I hope you're taking something away from today and are leaving excited and inspired by the power of ArcGIS. Personally, a key takeaway from today for me is the importance of nurturing and supporting the next generation of geographers and GIS experts. The industry is crying out for new talent, and it is the responsibility of all of us in this room and those joining online to inspire future generations. So thank you all for joining us again today. I would love to invite you for a drink just outside the main hall. I hope you all have a safe journey home, and we will see you next year. Thank you.